In this lesson, we are going to discuss solubility. By the end of this, we should understand that solubility of a solute depends on the temperature of the solvent and the substance of the solute itself. We should be able to read and interpret a solubility graph, and we should be able to calculate the solubility of a given substance at a given solvent temperature and a given amount of solvent. So, first off, solubility is the amount of substance that will dissolve in a given amount of solvent. Normally, in our course, the solvent is going to be water. That's what's doing the dissolving. It's the dissolver. That's why the solvent. So just remember that. That's the V, the dissolver. So right here is an example of a solubility graph. And this is for the substance KClO3, potassium chlorate. And on the y-axis, we have grams of solute per 100 grams of water. Now, it's very important to read the axes of the graph. The axis gives you information on what the graph is explaining and what the relationship actually is. So, on any point in this line, it's the amount of potassium chlorate that will dissolve per 100 grams of water, and that's an important thing too. On the x-axis, we see it is temperature in degrees Celsius. So, how am I going to apply this? So, let's say we wanted to find the solubility. We look at the temperature of the solvent. So, let's say at 30 degrees Celsius, what is the solubility of KClO3? So what we do is we go up to 30 degrees Celsius, check that out, and then we figure out how much will dissolve. And we go, and that's what we read on our y-axis. So we look there, and we see, we take a look at the graph, and we see that there will be 10 grams of KClO3 per 100 grams of water. And that would make the solution saturated. So what does this mean? So for every 100 grams of water, and remember, that means for 100 milliliters as well, since the density of water is 1. The most KClO3 that will dissolve is 10 grams. So, what if we don't, what if we want to apply this to ask a question? In 100 grams of water, at 30 degrees Celsius, will 15 grams of KClO3 dissolve? Well, the maximum up here, the most that will dissolve, is 10 grams. So, let's think about that. So, the most that will dissolve is 10 grams. So 10 of it will dissolve, but 5 will remain not dissolve. 5 grams of KClO3 will not dissolve. Now, that is kind of like if you have a nice coffee and you add some solid sugar, a little bit of it will dissolve, but the rest will just sink to the bottom and remain undissolved. So, let's apply this question a little more. In 200 grams of water, will 50 grams of KClO3 dissolve? So now we have to take into account that we have 200 grams of water. We have more water than we did in the previous problem. So, we have 200 grams of water, and let's look at this axis again. And we know that 10 grams of KClO3 will dissolve per 100 grams of water. And then we get 20 grams is the solubility. So, only 20 grams of water will dissolve. So, in this case, 30 grams will not dissolve. So, similar to the last one. We're going to get some more practice in this. This is a very important exercise in graph reading. And we're going to do it for a couple days. So, and we're going to use these skills as we move on. So, get used to it, guys.